Okay, this is problem number 9 on chapter 8, section 3. Um, as always, pause the video and read the problem. Identify the mean and the null and the alternative hypothesis. So pause the video. Okay. By this point, I have done so many videos, so you should be able to identify this null and alternative hypothesis. And the claim in this particular situation is on the alternative hypothesis, because the claim is that the population mean is less than 11 micrograms per gram. Okay, so this is my claim. My claim is right here. Okay, we need to determine the test statistic, and we are given the data set here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So a sample size of 10, and we need to get the mean of this data set, as well as the standard deviation of this sample. For that, we go to Stat. We type number 1, which is edit, and type all these numbers on L1. Okay, I already did it before starting the video, so I have these numbers ready. And we go to Stat, calculate, number 1. On list, we leave it like that, L1, frequency leave it in blank, and calculate. We have done this before in other problems. I will capture that screen. Okay, and okay, I will get the mean, which is 7.65, and the standard deviation, which is 5.3 in this case. To identify the test statistic, I use that formula that says the test statistic is equals to the sample mean minus the mean assumed, in this case the one that is on the null hypothesis, over the sample standard deviation divided by the square root of the sample size. So let's type 7.65 minus 11, all this divided by 5.3 divided by the square root of, we have 10 elements, and type this this in the calculator, clear, and I do 7.65 minus 11, enter, all these divided by, I open parentheses, 5.3 divided by the square root of the sample size, in this case 10, and I get out of the root and close the parentheses. Okay, I hit enter, and this is the test statistic right here. So they rounded up to 2 decimal places. Okay, so negative 2.00. Okay, next part is finding the p-value. Well, for this particular situation, we have a left tail. Okay, we have a left tail. Okay, we have here left tail in this situation, and my test statistic is right here. negative 2.00. The t distribution requires the degrees of freedom, which is 9. Remember that is n minus 1. And the p-value is pretty much the probability of getting a test statistic like that or less than that. Okay, so that you will find that area right here. Let me remind you again that this is a left tail because the alternative hypothesis has this a mathematical symbol to the left. Okay, so I open the calculator, I will get this area. So press second bars, number 6, which is TCDF. My lower limit, you might leave it like that, or you might type negative 10,000. I'll leave it like that in this case. The upper value is negative 2.00. Degrees of freedom is 9, and I paste that information on the main screen, and that's how I get that p-value. So let me show you the shortcut for this particular problem, guys. If you go to Stat and go to Test. Okay, by the way, for all these, I mean, you need to have all these data set ready. I mean, you gotta have that data set here. Let's go back here to Stat, Test, and select number 2, t-test. In this case, we will highlight data because we have the actual numbers in the sample size, and the value in the null hypothesis, I mean the assumed value is 11. List is L1, leave it like that. Frequency 1, leave it like this. And the mathematical symbol on the alternative hypothesis, which is less than, presented to highlight it. And I like to click on draw. You can also click here on calculate. Click here, and you will see a left tail test with that test statistic and this p value, the one right here. Okay, so last part I need to write the conclusion. For this particular situation, the p-value is